happiness and joy. Okay, so normal distributions, this is going to be a relatively quick, very similar to what you did for today. You know how today all you did was you're like, let's pick the numbers out of the, it's so easy. Hopefully everyone got 100 on this quiz. You know, which of the numbers is in? I don't know, the big one. And then which one is p? It's the only one that's like a percentage or a fraction. And then the x is the small number. So it's the same deal with the normal distributions, is you're just picking numbers out, at least for now. We'll deal with them next week. So a normal distribution is this sort of gold standard for all of statistics, as we're going to learn about probably after the break, or maybe it'll be next week, I think, is every distribution, it doesn't matter if you have a binomial distribution or anything like that, any weird distribution, you can turn it into a normal distribution. A normal distribution looks like this. Next Monday, I will bring, I gave you at least one normal curve. Here's one here on this quiz. So you're familiar with sort of this bell-shaped curve, but I've got sort of a template where you can download and print a whole page of those curves so that you don't have to draw them yourselves. But that's what it looks like, and we've talked about it some when we were doing the empirical rule. But what we want to do with this is we want to use it to compute probabilities. Before we can do that, though, I need to make sure that we can sort of orient ourselves to this curve. And I know we've already done this a little bit with the empirical rule, but in general, whenever you have a normal curve like this, nice bell-shaped curve, this middle is the mean. So it's the mean, and we use the symbol mu. And I know I've gone over this before, but to make a mu, which I know the students seem to have a lot of trouble drawing both normal curves and this symbol mu, you do a u, and then put a tail on both sides, but make the tail on the left a little bit bigger than the tail on the right, and that's what the Greek letter mu looks like. So you're going to be okay with that. Okay, so getting back to this, the mean is the middle. The mean is the middle, and the standard deviation, so on this particular curve, the middle looks like it's about at 2 maybe. It's going to be my guess. Standard deviation is the distance from the middle to where the curve stops getting steeper. So let's see, it looks like it's stopping, sorry, it's moving around so much. It looks like it's stopping getting steeper right about here maybe. I'm just going to take a guess. The same thing over here. This is symmetric. And so this distance from there to there. So to me, it's looking like the standard deviation is about 3.3, if you believe those numbers down there, because the distance between 2 and whatever this point is, that's the standard deviation. So and it's going to be the same this direction as well. If you subtract 3.3 from 2, you get negative 1.3. So that's pretty simple. So a typical normal curve looks like this, but every time we encounter a normal curve, it's going to be shaped a little bit differently. It'll either be, well, here I'll show you some examples. Well, here's one. You'll see this one is taller. This one is shorter and fatter. This one's kind of in between. I don't know, that one's kind of even shorter and fatter than the other one. So these are all normal curves, but they have different properties. And so when we look at a normal curve, you can pretty quickly figure out the properties of the normal curve by looking at the shape of it. So that's what I want to go over now, is the shape of the normal curve, so that we can sort of recognize these relationships. And I'll even tell you what the quiz will be like on Monday. In fact, I'll show you. Well, one of the activities we do here is going to be basically the quiz. Anyway, so let's take a look at these. All of these normal curves, and I know that you can't see them at the bottom there very well, but those are all normal curves, and they all have the same middle. So you'll notice that this red one is tall and skinny. The blue one is a little bit shorter and a little bit wider. And then you have this, I guess, puke yellow. I don't know what you call that color. That one's shorter still. And then this green one, you might not have even noticed that at the bottom. That green one is really short and really wide. The difference between these is the taller and skinnier it is, the smaller the standard deviation. So this one that's really tall, that one, just a sec, see if I can do this without touching the screen. That one there, that one has a very small standard deviation. So the standard deviation for that is really small because all of the stuff is kind of crammed in here. And so it's really skinny. It's a small standard deviation. The one that's way down there, the one that you can hardly see, that one has a really big standard deviation. It's really spread out. So this is a big standard deviation. It's spread out a lot. So that's what it means to be a big standard deviation, is for it to be spread out. A small standard deviation means it's crunched together, and when you crunch it together, it kind of squirts up, kind of like a balloon. If you have a water balloon and you squish it, it'll kind of poke upward in the middle. So there's that. Those all had the same mean, and then these all have the same standard deviation. And the reason why I say they have the same standard deviation is it's the same shape. They're all spread out the same amount. So those normal curves, they all have the same standard deviation, but the means are different. So here, this has the smallest mean, and the mean is the middle of the curve. And this one over here has the biggest mean, the biggest mean. So it's pretty easy. I'm sure you can do this. In fact, I'm so confident. Let me just show you this next one. Here's the sort of question that you're going to see both on the quiz on Monday and in addition to another question. I'll show you both questions. And we're going to be done with these questions probably early. So it's good that I had the problem today, because today's a short lesson. These three curves, here's the questions that I want to ask. Number one, which one has the smallest sigma standard deviation? Which one has the smallest standard deviation? Is it A, B, or C? The next question, which one has the biggest or largest standard deviation? Now you can guess what the other two questions are. Which one has the smallest mean? And which one has the biggest mean? And I was so distracted by our visitor that I didn't even take attendance. So I can't yet randomize, but you can write down your 4 answers. So write them down. Don't just memorize them, because I know you can't keep 4 letters in your head at the same time. I know some of you are probably better than me, so maybe you can. But I'm going to just take attendance, and I'll randomize and pick some people to tell me the answers that they got. Let's see, take attendance. Who's not here again? We have, let's see, this guy's not here for some reason. That guy, maybe he's still sick. I don't know. Who else? Oh, she's not here. Why isn't she here? Okay, I think I got everyone else who's here. All right, let's do this. Randomize. All right, Bailey, which one of these has the smallest standard deviation? B. It is B. Why do you say it's B?
It's just scrunched together. It's not spread out.
So you're looking at how scrunched it is this way. So bear in mind, one of the big mistakes that some students make when I ask them which one has the small standard deviation, they'll pick A, because A is smushed down this way, but standard deviation, you're smushing it this way, and it kind of pokes up. So the tallest one is actually the one with the smallest sigma. Very nice. Good job, Bailey. Next, we have Gabrielle. Which one has the biggest standard deviation? It is A. Very good. So it's kind of the opposite. There you're looking for something stretched out, squished down. Very nice. Okay, so what else do we have? We have the mean. So Marlon, which one of these has the smallest mean? So you're looking at the middle of the curve. So I think I misheard you. So the middle of A is right here, the middle of B is right here, and the middle of C is right there. So which one, I think I missed, which one did you say? The one with the smallest middle. So which of the middles is the furthest to the left? Oh yeah, that's right. Okay, I think I just misheard you the first time. So it is A because we're looking at the middle of the curves, and A has it's this. We're looking at the mean now. The middle is the mean. This one's the furthest to the left. All right, now that we've got that out of the way, I'll bet we can do this one. Alex, which one of these has the biggest mean? It is C. It's the one with the middle that's the furthest to the right. Very good. Okay, well, that wasn't too bad. So now that, and it's good to sort of get your, in fact, oh, I got to tell you, I was listening to an interview with, who was it? Ah, man, I can hear him talk. Anyways, this guy that's like this famous writer, but he was saying that he made a huge mistake and it was like really public. And he said that it really helped him because he was very motivated to fix that particular mistake in the future. Uh, and so if you didn't get these right, you should be happy. He said he was like this. It's only when you make mistakes that you have opportunity to learn. Neil deGrasse Tyson also talks. That's not who I was listening to, but he also talks about this idea that when you make a mistake, that's when you learn. It's not when you get it all right. If you get it all right, you haven't learned anything. So well done. If you got any of these wrong, you should celebrate because it's not a quiz. There's nothing to do. Okay, we're going to use this sort of notation to denote a normal curve. So just so that you can see what it looks like and you don't get confused when you see it in your homework. So what you'll see is you'll see that you have some x here. That's the random variable. Like maybe I'll do, well, here, down here, for heights of min. So min's heights are approximately normal. So the little tilde is just like, well, it's about normal. It's not exactly normal, but close enough. So the min's heights are approximately normal. So you'll see something is approximately normal. So the in means normal. And so when you see the in there, you should be thinking one of these. Then in the parentheses, the first number is the mean. So that's the mean. And then the second number is the standard deviation. So whatever numbers are in the parentheses, that tells you the mean and the standard deviation. So you can see at least the way I've done this, and I got to admit that I just change these numbers however I feel like it each time this shows up in the lesson. The heights of men and women, the mean is always 69 and 64, but I just change the standard deviation to suit whatever I'm doing. So in this case, the way that I've written this, the men's heights have a higher mean, but a smaller standard deviation. So their curve will be further to the right than the women, but it'll be more compressed, more compact, a little taller. The women's heights are further to the left, but they're a little bit more stretched out. So that's the deal there, more spread out. Okay, make sure we got this. Okay, so a quick review, now that we've got that out of the way, notation and graphs. Let's do a quick review of z-score just to make sure that you remember this. And I know you did this, and everyone did a great job, but let's make sure that we've got this. See if you can remember how to do the z-score. And now it's in the context of this, so that I have this notation for my test scores, although I actually wrote it in plain English up here. And I want to know Jimmy's z-score if Jimmy got a 93 on this exam. Take a minute, work it out, and then we will do it together. All right, Cooper, I see you're taking notes in your head. So what do you think of Jimmy? What's his z-score? Very nice, 84 over 5. And of course, you can do that because you're a professional mathematician, and you got 1.8? Okay, very nice. Did I get that right? Or did we get it right since both of us did it in our head? Okay, our heads. Very nice. So that's Jimmy's z-score. Jimmy's z-score is 1.8. Okay, now if I told you Jimmy's z-score was 1.8, what would you say about it? Like, what does that mean in terms of whatever. Like, does it mean anything? Maybe it means nothing to you. Mason, what does that mean to you that Jimmy's z-score is 1.8? That's right. It's related to the standard deviation. Very nice. So this is 1.8 means that we're 1.8 standard deviations from the mean. Very nice. Is there anything else we can say about Jimmy's z-score? I've already picked on you once. Calvin, I haven't picked on you. What do you think of Jimmy's z-score, Calvin? Is it unusual to see someone with a 1.8? No, it's not that unusual. You probably have a 1.8 for your height, don't you? Probably. I hope you calculated it. But anyway, yeah, so it's not very unusual. You remember that we talked about two standard deviations. The empirical rule says two standard deviations is 95% of everyone. So 1.8, not very unusual. A couple other things, just so that we can, complete this thing is it's positive. So we know Jimmy is above average for his test score. So if you have a positive z-score, you're above average. If it was negative, it would mean that he would be below average. And since this is a test score, we're happy for Jimmy, aren't we? He's doing well compared with the rest of the class. In fact, it would be nice to know where he fits in terms of the percentile, but we'll get to that. That's on Monday. Okay, so here's some more fun we can have with z-scores. I know you thought that we were done with z-scores, but here's a few more types of questions we could ask. And I think that these are on your homework. I can't remember if this is in your homework for today or some other time. But you'll have some questions like this. So let me do the first one, and then you'll do the other two. It says, suppose that you have a score of 75, and that the z-score is 3. So let's see, here's what I'll do is up here, I'll write the z-score formula, x minus the mean over the standard deviation. So that's the z-score formula. It looks to me like what I'm being asked to do here is to do some algebra. It's not hard algebra though. It says the z-score is 3. So I'm going to put 3 in place of the z. It says x is 75. And it says that the mean is 66. And I want to know the standard deviation. So there's the expression. And I know that you probably thought that you were saved from algebra when you finished your whatever algebra course you had, but there's a little bit of algebra here. And if you think about it, a lot of what we do in a spreadsheet is just algebra, thinking about moving, manipulating numbers around. So knowing your algebra is going to be helpful. This is pretty basic though. So let me remind you how you solve that equation. We're going to multiply both sides by sigma, and that'll give me 3 sigma is equal to, I'll actually do that minus as well. 75 minus 66 is 9. And then you can divide both sides by 3, and you get sigma is equal to 3. So value of sigma is 3 for this one. Okay, the next two, they're completely different. See if you can compute those. I'll bet you can. I'll give you a minute just to practice. Let's just do this. Hold on a sec. I'm logged into multiple devices here apparently. This one will go away. All right, let's see how we're doing. Where's my randomizer here? I know you love it when I use this because I get feedback at the end. You know how you get to write? People say, we love it when you randomize. It's so much fun. Okay, Haley, what is this sigma for this one here, the number 2? You got 8. That sounds pretty good to me. But if anyone doesn't have 8, we can work through the algebra. It's almost the same algebra as this. So, no complaints. All right, very nice. Let's do this last one. And who gets to show off? Oh, already bugged you. You've bugged. Oh, AJ, though. AJ, what do you think? What's this one?
I got
9.28. That sounds about right. To be honest, I didn't do that one because I can't do that in my head as easily, but you probably did whatever the difference of 35 and 63 is and divided that by 3.45.
35 and 67.
Oh, yes. Let me work on my caffeine intake. Okay, yeah, good. Good job. Let's move on. So, as you can imagine, we could have even more fun with z-scores if we ask a slightly different question. So we'll just do one more of these, but you could do this all day long, you know, and leave out one of the 3 things about the z-score and then try to figure out the one that's missing. So just as an example, let's say that we have x is 75. Let me write down the formula again. Whoops, get rid of that. No, come back. Okay. Okay, so we have x minus the mean over the standard deviation. So if we know x is equal to 75, we know the z-score is 3 and sigma is 16, and we want to know what the mean is. We could do that using algebra. And just to prove it to you, let's go ahead and do this one. So multiply both sides by 16, and you get 48 is 75 minus the mean. It always bothers me when my letter, and I know you don't think of that as a letter, do you? But it's a Greek letter. It always bothers me when it's on the right side, so I'm going to add it to both sides. So add that to both sides, so I have mu plus 48 is equal to 75. Sorry, I've run out of room, so I'm just going to keep going down. And then subtract 48 from both sides. So mu is equal to 75 minus 48, which is 27. So that's my answer for that one. Wow, this is almost the same stuff. Yeah, let's not do this one. Just do this one just to make sure that you can do this. And then we'll go to the final slide here. So give the second one a try. You might have already done it while I was blabbing. Just checking my what's coming up. Darn it. I have to fix something. So much better. Okay, let's see how we did. I should have picked my volunteer before. Here we go. Evan knows how to do this. Evan, what did you get for this one?
I can't figure it out.
Oh, but you know how. So you're just holding out on me. Let's go ahead and do it together. We have a z-score of negative 2.5. So I'm using this formula with the numbers that are given here. So negative 2.5 is the z. And then x is 43 minus the mean. We don't know what the mean is, but this is going to be divided by sigma, which is 6. So it's negative 2.5 is 43 minus mu over 6. So surely you could do that. And I see the problem is you don't have your calculator or a piece of paper, but you tell me what to do. I'll be your calculator. So what are you going to do to this equation to solve it for mu?
Multiply negative 2.5 by 6.
That's it. Multiply negative 2.5 by 6. Very nice. I was trying to hint at it without being too obvious. So that would give me 15 or negative 15 because it's negative. All right, keep going. We're almost there. Now what? Okay, subtract 43. I'll do that. So let's see, subtract 43 from both sides. That leaves this as just negative mu. On the right side, I have negative 58. Almost done. Now, what's the last thing? Take away the negatives. It's the same as multiplying by negative 1. So that means that mu is 58. Nice job. All right, good work. Okay, last thing. Does this all appear? It does all appear. Why does it all appear? Just a minute. It's not supposed to all appear at once. Let's see if I can make it not all appear at once. Probably not. Well, apparently not. That's okay. I'll just have it all appear. Okay, so this is just a reminder of the empirical rule, and I know this is more complicated than what I told you before. The important stuff are these numbers: 68, 95, 99.7. Just a quick reminder. You might wonder, where did those numbers come from? Well, those are the actual numbers. So we're going to be learning about how to compute those numbers next Monday. But for now, we're just going to use those three. So this is approximately 68%, which means each of these is approximately 34%. Those are approximately 13.5, so that you can add those up and get 95%, and so on. So 68, 95, 99.7. Let's use those to compute or approximate the percentage of people that fall within each of these categories. And I'll try to figure out why it didn't copy over. It's probably the whole connection thing. Maybe that guy, I need to call him back, but it'll be okay. All right, I'm just gonna, I can just freeze this so you don't have to be annoyed. Hold on a sec. Since I didn't have it set up earlier. I just want to be able to make my normal curves easily, so I'm just copying some normal curves. Almost done. All right, that wasn't too bad. Okay, let me show you this. So this is the sort of thing that you'll see on your quiz as well as on the exam next week. Hopefully this weekend I should be able to get something online for you to study for the exam next Friday. But for now, let's take a look at these. So whenever you see a mean and standard deviation for something that is approximately normal, usually it tells you you should immediately draw a curve. And I know it's not popular to draw a curve because I've seen you, at least some of you in my office, and you don't draw. So let me do this. I will have the curves on the test for you. So there it is. I've just marked off the standard deviations for this. So you start at 100, go up by 15, down by 15. I want to know what percentage of people fall in each of these categories. So that's why I've got, oh, I just realized. Can I just delete those? Hold on a sec. I can. Okay, give me a sec here. I'm going to copy that whole thing. Oh, good enough. One more. There, that way I don't have to rewrite. Okay, so I want to know what percentage of everybody is between 70 and 130. So here's 70 right here. Here's 130 right there. And I want to know what percentage fall in that category. And you're going to use, at least for now, you're going to use empirical rule. And I know you've done empirical rule before, but there's a reason why we're going to do it this way one more time, last time. Okay, so who is my next volunteer? You've already volunteered for me, but Amy, you wanted to volunteer, didn't you? Do you know what percentage fall in that range? Almost. So I think you went one too far. So this is 2 standard deviations, not 3. 95%. Yeah, so Amy has these 3 numbers memorized. 68, 95, 99.7. This is the second because there's 2 standard deviations. So that's going to be 95%. Beautiful. Okay, the next one is, and I need to make this bigger so that, whoa, put it over here so I can draw on it better. So I want to know between 100 and 145. 145 is 3 standard deviations, 145. So I need to go between this and this. Ooh, it's hard. You can hardly see what's going on, can you? Like down there, it's so small. It's okay. So to do this one, we're going to do this in stages. I'll have 2 people work with me. The first one, the first person is going to tell me about the 3 standard deviation number, and that's the percentage of people between 55 and 145. So let's deal with that first, because you can see, hopefully, that this is exactly half of the 3 standard deviation number. Okay, so let's see. You've already done number. 99.7, that's beautiful. So that's how many people would be in that whole range. And now we just need to do half of that. And so easy, you can just do it on your calculator. Mason did it on his calculator already, didn't you? What did you get? Wow, 49.85% is right there. Okay, we actually have 2 more. I know that it looks like just 1 more, but we have 2 more. Let's do the 115. And then we'll do the last one, which is, it didn't show up. I don't know why it didn't. So let me draw 115 is right here. So you can see where 115 is, and I'm interested in more than 115. So I would shade this way, all the way out. Everybody that's over there. Now to compute this, I'm going to have to do a little bit more sort of algebraic thinking because that's not one of my standard ranges. So let me just back off just for a sec and talk about this range. So this purple range right there between 85 and 115. So let's get that percentage first, and then we'll use that as a stepping stone to get the next one. So Aubrey, do you remember what percentage are 1 standard deviation away from the mean?
68.
That's right, 68. So this is going to be 68%. Now see if you can figure out how you're going to use that number to figure out what this number is. So that number, and that's all the way out there. So take a minute, see if you can work it out. If you can't, I'll help you, don't worry. There's a couple ways to do it. That's the reason why I'm hemming and hawing. All right, Abby, were you able to do this? Do you have a number for me?
32.
Ah, very good. I like that number. So how did you get 32?
I subtracted it by 68 by 100.
Okay, so 100% minus 68% is 32%, and that is perfect. That is the number that is outside the 68 band. So let's do this. So very nice. 32% belongs in that area there. So think of it this way. We're not quite done. So Abby's given us the stepping stone. We're almost there. But think of it this way. You've got 68% of everyone is in this middle section. That means that 32%, the rest of the people, are in the extremes. Some of them are low IQ, some of them are high IQ, but they're out there one way or the other. Now that we've got that, we're going to have to narrow it down and figure out just the people over here. So it's not that we don't care about these people, but the question is just asking about those people. So let's get that last step one more step. Blair, do you know what the last step is now that Abby's given us this part? So you've got the low IQ people, the high IQ people, the total is 32%. Those look really similar, don't they? They're like the same shape. They're just mirror images. So wouldn't it just be that they're the same and they add up to 32%? Can you take a guess? Very good. 32 divided by 2. I know it's early. It's still early for Blair. It's early for me too, but I've just been drinking coffee all morning since about 6:30. Okay, so very nice. So you have this group. Oh no, it went away. I didn't want it to go away. You have this group and this group. Total is 32%. So the group over here is going to be 32% divided by 2, which is 16%. Perfect. So that's the answer there, 16%. All right, there was one more, and then we're all done. Look at this. We're going to be done a little bit early. So I got to just have to find there it is. It didn't show up on my PowerPoint on my iPad for some reason. So I'm just going to write it here. The last one is less than 123. Less than 123. Okay, so it's the same question, the same stem, and it actually shows up on my PowerPoint here. I don't know why it didn't show up on the iPad. Less than 123. So let's figure this one out. Give me a sec. I have to start by drawing the curve again. So we start with this, and the question is less than, I'll put this again, less than 123. So the next step is to draw on the curve where 123 is. Let's see, there's 115. 123 is kind of in between here, isn't it? Let me change the color here so we can actually see it. There, it's kind of like there, isn't it? You're kind of in between the two numbers. So the empirical rule would help us out if I was dealing with that number or this number, but this is in between. Now I can certainly shade this. This is what it means to be less than 123. I can guess, if you had to guess, what would you guess that number is? I don't know, maybe 90%, maybe 85%. But I don't have an empirical rule that helps me with this particular number because 123 is not right on one of the standard deviations. And so what we're going to do is we're going to take this problem and we're going to do the same thing that we did with the binomial distribution. So you remember with the binomial distribution, you were asked 3 questions. The first question was, what was in? For normal distributions, the first question is always going to be, what is the mean? The second question with your binomial distribution was, what is p? For us, in the normal distribution, you're going to be interested in this. And then the final question with the on the quiz was, what was x? So here, x is 123. So what we're going to do is we're going to eventually, on Monday actually, take those and punch those into Excel. So to do this, we're going to have to rely on Excel. So that will be Monday. So this is a quick preview. You need to bring your computers on Monday. And if your computer is terrible, go get one from the library. Although, actually, I hate to do this, but I think that even if you have a terrible computer, you will be okay on Monday. Even the iPads. I think the iPad will even do what we're doing on Monday. We're doing some pretty basic stuff on Monday with Excel. So bring your computer Monday. There is homework for this weekend. It's all pretty straightforward, though. I think you'll be fine. So we're done a little bit early if you want to stick around and chat. Otherwise, have a great day.